A very good afternoon to one and all present here. I am Yogalakshmi. Feel privileged to welcome you all on 2 days of ninth Agricultural Graduate Student Conference, AGSC 2024, Commercializing Agro Technology, Invest, Innovate, Incubate. We privileged to be joined by like-minded people from the different fields of agriculture and allied sectors. This conference intends to provide a forum where we can exchange, learn, and adopt different and new ideas for better tomorrow and to elevate and rise the respective sectors. Today, the theme 2, which will be the central pillar for all presentation, is trends and challenges in soil crop management. We are aiming for having productive presentations and fruitful discussion. With this intent, let us begin the today's sessions. The session is being chaired under Dr. K. Jayabhaskaran Sir, Principal Scientist, Soil Science, iCare, National Research Center for Banana Trichy. The co-chairman for today's session is Dr. P. Balasubramaniam, Director, NRM. Dr. M.K. Kalarani, Ma'am, Directorate of Crop Management, Professor and Head SSNAC, Dr. D. Selvi, Ma'am, Dr. P. Parasuraman, Sir, Professor and Head Agronomy, will be the member of today's oral session. Dr. Ga Deeba Garan, Sir, Associate Professor Agronomy, Rapporteur Faculty, and Mr. T. Naveen Kumar, second PhD Agricultural Nanotechnology as a Rapporteur student. Now, I request Dr. P. Balasubramaniam, Sir, Director NRM, and Dr. M.K. Kalarani, Ma'am, Directorate of Crop Management, to honor the chief guest with book. Thank you, sir. Now, I would like to invite Dr. P. Balasubramaniam, Sir, Director NRM, to deliver the welcome address.
The most respected uh, Dr. K.J. Jayabhaskaran, my good friend, Principal Scientist, National Research Center for Banana, Tiruchirappalli, and Co-Chairperson, Dr. Madam Kalarani, my Crop Management Director, and Head of the Department, Agronomy, Dr. Parasuraman Sir, and Dr. D. Selvi, Soil Science Head of the Department, and more and above, all the student friends. Good evening to everyone. Good afternoon to everyone. Of course, now time 3:30 started. First, I am very happy to welcome our today's chairpersons of this session, Dr. K.J. Jayabhaskaran, that is the soil crop dynamics, trends, challenges, and solution. He is the right person to be here as to share the session. Yeah, because he has had a vast experience in the soil and crop management, particularly in the field of banana, especially the banana crop. It is a horticulture crop, fruit crop. He is experienced in the almost his life service. He is my friend at Annamala University. We were studying at Annamala University. He was a very right person. Well, he has been selected by the Tamil Nadu Public Service Commission as a direct recruitment of the assistant soil chemist originally. You know what is assistant soil chemist? It is an assistant director of agriculture. Now you know the horticulture, the assistant director of horticulture being recruited directly. Like that, he was directly selected by the government for the assistant soil chemist posted in Ooty. He was heading the laboratory, but he quit that job. He left that job. He joined in ICR because of his interest in research. That shows his interest in research. He joined the ICR by leaving a high profile position in the state government. He left that post and he joined the ICR as a soil scientist in NRC and banana. He continued to work in the institute. That institute was started in very recently in Tamil Nadu. This is the last institute started in Tamil Nadu among the ICR institute. He joined there as first soil scientist. He joined there. He has worked in he got external funded schemes from DBT and DST for there were several fertilizers, customized fertilizers for the different banana varieties. He has developed different customized fertilizers for banana varieties, particularly the role of potassium in banana. You know very well the potassium is important nutrient which will have the mitigating the biotic and abiotic stress. You know the banana is being grown in several ecosystem, wetland banana and garden land banana, like that several ecosystems. There were varieties of banana is there. So he has developed customized fertilizers for banana and especially the micronutrient mixer. And he has also developed a soil nutrient budgeting for the soil plant ecosystem and banana cultivation and quantified the nutrient removal and recycling of banana ecosystem. Those things have been studied. He has published his research article, more than 70 publications. He has is a peer-reviewed journal with more than NAS rating 7, and the publication in the international journal and as well as the national journal. And with vast experience, I welcome Dr. KJ Jayabhaskaran for this session to chair and have an interaction with our students and give it will really it is going to useful for our students. Next, I welcome our Director Crop Management. Madam is always busy with a diversified and multi-variated work she is assigned by the university. So Madam is in charge for the security. Madam is in charge for the directorate and so many other works Madam is handling. In spite of that, Madam is very busy. Thank you, Madam. Welcome, Madam, for this session. And I welcome Dr. Parasuraman sir for this session. He's head of the Department of Agronomy, is all along supporting the Directorate of Crop Management. And I welcome Dr. Selvi, Soil Science HOD, for this session. I welcome all the students for this session to join. And you have an interaction is more important rather than presentation. So whatever the presentation is there, you please interact with all those who is presenting. Then only the committee can able to evaluate the performance of the students. Okay. With these few words, I welcome everyone. Thank you very much for the opportunity. Thank you.
Thank you, sir. It will be a privilege for me to invite Dr. K. Jayabhaskaran, sir, Principal Scientist, Soil Science, ICARE NRCB Trichy, on the stage as the lead speaker for this event. I express my sincere gratitude and welcome you, sir, to this conference. He indulged cement kiln flue, dust, and alcohol distillery effluent as potassium sources in banana production and developed DRIS indices and chart for Nendran, Neipuvan banana. He created a banana micronutrient mixture called Banana Shakti and also developed fertilizer tailoring equation for banana varieties like Nendran, Poovan, Neipuvan, Karpuravalli, Rastali, and Grand 9. He published articles in various journals that include International Journal of Innovative Horticulture, Indian Journal of Horticulture, Indian Journal of Agricultural Sciences, the Andhra Agricultural Journal, South Indian Horticulture. He is currently working on the development of club management technology, organic banana farming, and nutrient dynamics in banana. Now, I request our chief guest, Dr. K. Jayabhaskaran, Principal Scientist, Soil Science, ICARE NRCB Trichy, to deliver the lead talk.
Okay, good afternoon to all. How are you? Fine, huh? Okay. So, as introduced by my best friend, Dr. Balasubramanian, I'm Dr. Jayabhaskaran. Basically, I'm principal scientist working in National Research Center for Banana. How many of you visited our institute so far? Very good. Okay. So, I have been working there from since 1996. The institute was started basically on 1993. But I joined there in 1996. From there onwards, I am working for banana and I have more than 30 years of experience in that actually. So here today I am going to concentrate on the soil health management through natural resource management, because nowadays always we are talking about, we are very proud about we have produced this much of food grain, 320 million tons of food, 352 million tons of horticulture produce. This much we are telling. We are very proud, but at the cost of what? We have spoiled totally our soil system and our crop system. Everything we have spoiled. That we are not understanding that. So for this, okay, let us see. You may be knowing there are some 16 types of essential nutrients are very essential for crop growth. For any crop, for banana also like that. But how much it is required for banana cultivation for producing optimum yield in 1 hectare of banana? Let us see. That nitrogen, these are all the macronutrients. Primary macronutrients, there is nitrogen, some 388 kg of nitrogen is required, 52 kg of phosphorus it is required. You can wonder that 1,500 kilos of potash it is required, because potassium is very much required by banana crop for better yield and quality also. Without potassium, we cannot get good quality and quantity of banana. So, because that much of potassium is very essential, and in case of in the case of a secondary macronutrient, calcium, magnesium, sulfur, how much it is required? See, some 227 kilos of calcium is required, 125 grams of magnesium is required, even some 75 kilos of sulfur it is required for a hectare of banana. In case of a micronutrient, these are all the things I have given in the descending order. Some 12 kg of magnesium is required, 6 kg of iron it is required, then 4.7 kg of zinc, 1.27 kg of boron, and 0.37 kg of copper. That's the least one. So these are all the very essential nutrients required for banana cultivation for getting optimum yield. So we have so far worked in different aspects like for natural resource management. In these aspects, in this category, we have taken this nutrient recycling because always nowadays we are talking about circular economics like that. So one way we have to recycle or reuse, like that we have to take. So that concept also we have done, and that the soil test based nutrient management STCR approach, we have developed some fertilizer adjustment equations also. So for that we have developed some fertilizer calculator, user friendly calculators also we have developed, and that organic and natural farming, then soil amendments in problem soils, because banana is not suitable for banana in problem soil. But even then we can able to get a good quality with the proper management of soil. That can be done with all sorts of things, and use of industrial waste. Sometimes this potassium or other essential elements are available in industrial waste. Nowadays what we are thinking as waste may be resource for some other place, because waste is the misplaced resource. Like that we can use some of the waste also for our banana cultivation. Then domestic organic waste, then integrated management, micronutrient management, soil management using tissue nutrient diagnosis. That is a DRIS concept also we have developed. Then improved techniques for high density planting. That is based on agronomic aspects also we have done. Let us see one by one what are the things we have developed in nutrient recycling or nutrient budgeting. You may be knowing that these are the budgeting system in banana system, where there are so many pools are there. So sometimes it may be available form, may not be available form, like that it is there. So once through rainfall also some of the nutrients is added. This is the plant system, you can see below ground and above ground system. And these are all the things where what sometimes nutrients are removed through bunch harvest. Any problem? So like the different pools are there. Sometimes when if you see the bunch harvest, whatever the nutrients it is applied, sometimes it is taken away by the uh, harvested produce. Sometimes it may be remaining in the residues. So this can be used for recycle purpose. So that type of strategies also we have developed. So for conducting this type of study, we have taken different stages, critical stages of plant system. Like that, we have collected the tissue samples at 10 leaf stage, 20 leaf stage, and shooting stage, harvesting stage. These are all the different critical stages. At the time, we have collected all the tissue samples, and these are all the system. Just for your knowledge, I am giving leaf, petiole, pseudostem, corm, root system. Like that, we have divided in the different segments. And the bunches also we have divided into peduncle bunch, male bud, like that we have segmented. So in that, how much nutrients are accumulated at different stages, that we have worked out. So like this, if you see this type of segments, below ground and above ground segment, 10 leaf stage, 20 leaf shooting, harvesting stage at 100% proportion we have worked out. In that, different maximum minimum values are there. So in the initial stage, all the nutrients are accumulated in the below ground. And the later stage, at the time of harvest, all the nutrients or the carbohydrate synthesized or translocated in the bunch. In the later stage, it is translocated to the bunch. So in the above ground system, all the accumulations are taken place in the later stage. So like that, we have worked out. These are all the proportions what we got it in that study. And in that, we have segmented in biomatter production, that is dry matter production, how much it is accumulated. If you take 100% as a whole of the plant system, in that some 14% it is accumulated in the leaf, petiole 3%, and pseudostem 27%, corm 14%, root 2%. In the case of bunch, it is 7% peduncle, 32% fruit portion, and 1% is male bud. Like that, we have segmented in different proportions in different dry matter productions here. So these are all the things. Then we have worked out the harvesting index. How much it is removed from the soil, or how much from the it is removed from the per unit area. So like that, we have worked out like some 38% it is removed as a bunch harvest. In that case, nitrogen it is 25% is removed. Say for example, if we are applying 100 grams of nitrogen, means 25 grams is removed through bunch. Only 75% is remaining in the residues that can be used for recycle purpose. In case of phosphorus, it is 34%. In case of potash, you see 52%. What are the 100 gram if you are applying, means more than 50% it is removed through bunch. Only 48% is remaining in the residues. That means potassium mining is taking place in banana cultivation. If you do continuously banana cultivation in the same place, continuous potassium mining is taking place. We have to replenish every time, every season. That's why it is very tedious, because the potassium is not available in banana in Indian condition. Always we are exporting from other countries only. So that way, we are facing a lot of problem in our country, because the government has to give more subsidy on potassium fertilizers. So they have to bear a lot of burdens like this. So in that case, how we can manage with this? So how much nitrogen dry matter fragmentation it is there given, and this is the nitrogen level. Say for example, some 120% it is removed. That is, say for example, if you work out all this thing, some 444 kg of nitrogen it is taken up by the plant per hectare for its total dry matter production. Through bunch harvest, some nearly 112 kg of nitrogen is removed through bunch. Remaining is 332. That means some 25%. I already shown the table. 25% it is taken up by the roots fruit harvest, and remaining is existing for the recycling purpose. Like that, phosphorus also we have worked out. 69 kg it is taken up by the total plant system. Through bunch harvest, 24 kg, that is accounting some 34% of phosphorus is removed, and residual is 45, it is existing for the recycling purpose. In case of potassium, you see 932 kg of potassium it is taken up by the plant system total as a whole. Here 485 kg of potassium is removed through bunch, and 447 kg of potassium is existing for the recycling purpose. But in this case, if you see this peduncle portion, it is having more potassium. But what in conventional method, what we are doing as a total bunch we are harvesting and it is marketed. So somewhere these fruits are dehanded and these peduncles are thrown away somewhere. So for that purpose, we are recommending farmers don't harvest it as a bunch. In the field itself, there itself, you dehand everything. Only fruits only you can transport to your marketing place through crates or something. That dehanding has to be done in the field level itself. Then only we can save this much of potassium. You see, some 196 kg of potassium, it's there in the peduncle itself. So there itself, we can recycle there itself. So that is the thing, we have to slightly modify our conventional thing so that all the potassium can be recycled in the field itself. So this is our recommendation. Like this, we are doing some budgeting studies, and this is a micronutrient aspects. So here also, in case of copper, 18% it is removed through bunch harvest. Then in case of manganese, 9% is removed through bunch harvest. Then 48% zinc through bunch harvest, 28% through bunch harvest in the case of iron. So these are all the fragments we have concluded that this much of potassium, this much of nutrients, this much of micronutrients are removed through bunch harvest. So this has to be avoided, and the rest of the thing has to be recycled there itself. That is our main aim. So like this, when we work out all this thing from 1 hectare of banana cultivation, so this much of nutrients it is removed through bunch harvest, and this much of nutrients it is existing in the plant residues, which can be utilized for recycling purpose. So when compared to this, the residual nutrients existing in the plant residues are higher in quantity than the bunch removal, except this potassium. So this is our botheration, how we can reduce this loss. So by that way, we can do some dynamic studies so that we can reduce this losses. This type of study is very helpful. And like this is the graphical representation, how much it is removed. That red bar, it is indicated through bunch harvest, a green bar, that nutrients available for the recycle purpose. So by this way, we can avoid most of the losses. All the nutrients can be recycled. Then in the soil, how much it is remaining after bunch harvest, after the bunch harvest, and after the season by season, how it is increasing or decreasing, like that we have worked up. Previously, I talked about the nutrients existing in the plant system, but now in the soil system, how it is working out. There is a budgeting study we have done. This is the initial values. So this is the initial values in the plant's soil system before banana cultivation. So this is the nutrient added through the fertilizers based on the blanket recommendation. So this is the total. This is simply mathematical calculation only. This is mathematical addition only. A plus B, like that, the column A and B are added. It is a mathematical calculation. This much of nutrient it is removed. I already shown these values. This much of nutrients it is removed for the total plant system. and the balance it is remaining. This is the mathematical, simple mathematical calculation only, but actually it is not existing like this because of the nutrient loss through some natural leaching or evaporation loss. So this is the mathematical calculation, simply estimated. There is the calculated one. This is the estimated one. So there are some differences there, you see. Here it is the lower value we get because of the leaching loss, evaporation loss, sometimes it may not be properly utilized or maybe transformation into other forms which may not be available to plant system like that. So this is the end of the first season, and this the same column, the last column we are keeping here in the first column, that second season, ratoon crop. So with this some 75% of nutrient it is added based on the blanket recommendation. Only 75% in the ratoon system we are adding. And this is the nutrients added through recycling of the first season crop. So whatever the worked out the values given, no, this is the C column, it is there. So altogether, it is the mathematical simply addition of that. And this is the uptake of the second season crop. And this is the calculated value, estimated one is like that. So estimated value is less than the calculated value. So once again, some leaching loss or some natural losses will be there. So like that, gradually we can do this sequence of budgeting in the soil. So this will give very good idea about the dynamics of the nutrient, how it is varying with the season by season. In the crop system, how it is varying, in the soil system, how it is varying. So like that we have worked out, and there are some correlation work we are doing. So that is why this session is mainly meant for this soil plant dynamics. So that's why this is the main thing I'm working with banana. You can do with some other crop also. This type of work we have to do. This is the nutrient budget. So then how we can utilize this all the residues? Because as such we cannot use in the soil and the fresh condition. That has to be properly composted. Otherwise, because if you take this pseudostem, fresh pseudostem, the CN ratio will be 60:1. If 60 parts of carbon is there and 1 part of nitrogen is there. So this much wider CN ratio will not be helpful for nutrient release, or it is not helpful to a cropping system. So in that case, we have to compose it with the help of some earthworm or microbial digestion also we can make. And with this, we can get a very good vermicompost. So by that way, we can reduce this CN ratio from 60:1 to 9:1. So by that way, we can made available for the plant system for as a nutrient source. So this is the thing we are doing. And always we are recommending don't apply the fresh material in the field for the nutrient supply. So it has to be properly composted out of the field, and the compost material has to be applied in the field. So that is our recommendation here. So with that, how much it is a nutrient, it is regained, and how much nutrient is existing in the vermicompost, that also we have worked out per plant, and per hectare calculations also we have worked out. So all this thing will be very helpful for nutrient recycling purpose. So that way, next season we can reduce our fertilizer input there. So these are the things. So once again, it is another graphical representation. You can see this 200 grams of nitrogen we have applied, and it is 117 grams of nitrogen we have recovered. So rest of the thing can be taken up by the plant system, and remaining is used for next season. In case of potassium, you see, potassium is very high. It is taken more, but it is removed through, it is available for the next season. Nearly more than 50% is removed. So that is main botheration for us. So how best we can save our potassium? Because so far most of the time we are importing from other countries only. We are going on adding potassium, but where it is going? So at a certain, because it is not a operating material, only thing is lost by the leaching loss only. So that has to be avoided. Then potassium dynamics also we have studied in the soil, how it is taking place. So in case of, you might have studied this aluminosilicate layers of a clay structure. So this is the thing, just thematic expression only. This is the potassium it is existing, where it is entangled in the layers, it is called in the specific site. Where it is absorbed on the outer surface, it is called a non-specific site. You may be knowing. So most of the of you studied this, you know, you are basically soil scientists, you know, everything, all the participants. No, okay. So these are the thing, basic thing. Just follow it. And when a crop grows, some of the potassium it is removed, and some of the potassium it is removed through bunch harvest. Some of the potassium it is removed. Finally, what happens? The same clay structure Only potassium is always exhausted. No? And next stage, what happens? Let us see. So once if it is added, once it is recycled, the potassium wherever it is existing in the specific site, it is added in the non-specific sites. So that it is the potassium buffering capacity of the soil is increased. Because whenever the potassium is lacking, if we are not able to apply potassium, the existing potassium can be easily available to plant system because it is available in the non-specific site. Specific site means it has to plant has to give more pressure. So like that way we have to work out. So that K specific site gets depleted and most of the K is replenished in the non-specific site. So this is the potassium dynamics we have studied, and this is the QA parameters. You might have studied that the QA parameters, no? This is the potassium existing on the soil, that is adsorbed on the soil. So this is the potassium level existing in the solution, because always the nutrients are existing in the soil in two form, only in the soil solution and another in the adsorbed form or the clay particles. So like that you have worked out, and this is the first season. This is the blue bar it is indicated, and the second season it is the steeper. The more the steepness, the more the buffering capacity of the soil. So when you recycle all this material or the residue material in the soil, that the potassium is getting adsorbed on the soil particle, which is easily available to plant system, and the buffering capacity of the soil is improved. That is our final conclusion. So another thing, potassium is available. The availability of potassium is based on the ratio between other nutrients also, because always there is some relationship between other nutrients. If you consider the activity of potassium, we have to consider the activity of calcium and magnesium also. So that is another thing, that ratio law. But always we are recommending farmers, if your soil is having 1 part of potassium, at least 10 parts of calcium should be there and 5 parts of magnesium should be there. This ratio should be maintained. Without this, if you just dump potassium, if you are not bothering about the ratio, that will not be helpful. So this is the main dynamics here. Here you might have studied the ratio law. That ratio law is working here actually. So if the activity of potassium is 1, the activity of calcium should be 10 and magnesium should be of 5. So this ratio should be maintained. So always this ratio is very important in banana system. For other crops, it may be varying, but this point you have to consider while working out on this type of study in other crops also. So where the ratio may be different, but here banana, this ratio is for 1:10:5. The same system I am just explaining. And these are the things at a given time of duration of the plant system. This much of nutrients are existing in different segments. Like that, it is worked out by Clifford Walmsley in 1974. So nitrogen, potassium, phosphorus, potassium, calcium, magnesium, these are all the ratios in the different segments of the plant system in the soil, how it is there. So like this, we have worked out. Then fertilizer tailoring. Because nowadays indiscriminate application of fertilizer is going on, because most of the time this blanket recommendation, the farmers are just going to the fertilizer shop, whatever the fertilizer shop owner is recommending, they are just getting the fertilizer and they are applying. They are not bothering about the how much nutrient is there in the initial soil and how much has to be applied to get this much of yield. So they are not bothering about it. So nowadays they are issuing this soil health card also. The issuing of a soil health card, with that along the recommendation of the fertilizers also we are giving. So for that, it will be very useful. And these are all the studies we have conducted in different regions with the different varieties. These are all the different calculation methods. These are all the basic things. Just I will show the what all the fertilizer adjustment equations what we have developed. This is the tailoring equations. So for different, there are so many varieties are there one in banana, in Nendran like this, and Rastali is this. What is this meaning means this is nitrogen, phosphorus, potassium. This is the one constant factor is there. If a farmer want to particular ton of yield in a given area, he has to multiply this value with 29.8. Then from that, how the soil is contributing nitrogen, that has to be deducted, and how the nitrogen is contributed from the organic matter. So that has to be deducted. Then exact requirement of a nutrient, how much has to be applied to get particular yield. So this is the equation we have developed. And for all the varieties and all the main crop and return crop for all the varieties, each varieties we have conducted. And these are more scientific. Sometimes farmers may not be able to follow this also. So for that, what we have done, we have developed some fertilizer calculators also using Excel package. A simple Excel package only. So this is very helpful and user friendly, and even you can download it in our Android mobile. It is very well available in our website also. Like that, the farmers are using now. Nowadays, all farmers are well versed in using computer or even Android mobile. But sometimes the conventional farmers, they may not be knowing how they can use this calculator and this thing. They are not well versed in that. So in that case, we have given this ready reckoners also. So these are all the ready reckoners. And say, for example, a farmer's soil is containing some 125 kg of nitrogen. A farmer want 72 tons per hectare yield. So exactly where it is meeting, 181 grams of urea has to be applied per plant. Like that, it can be worked out. So there is no need of applying more nitrogen or more potassium like that. Exactly, we can work out based on the initial soil test values. So this is the ready reckoner we have given. So most of the farmers, they are adopting this. For all the varieties, we have developed this type of ready reckoners. And like that, this all the fertilizer equations we have validated in different agroclimatic conditions also. Before recommending to the farmers, it has to be tested in different agroclimatic conditions. Multi-locational trial we have to conduct. So like that, we have conducted in All India Coordinated Research Project in different in 6 or 10 agroclimatic conditions are there. All there we have given all these equations in different varieties they have conducted, and it was test verified and found it is fit for all locations. Even then, it is having some elasticity. So beyond a certain limit target, it will not work. So that elasticity limit also we have found out in different. This for granite variety. So these are all the blue bars. It is indicated the target what we have fixed, and based on that we have applied fertilizers based on our fertilizer calculators. But after reaching this 105 tons per hectare, the yield is decreasing. Even we increase the target, even we after application of the required fertilizers, the yield is declining. So that means some negative response is there. So declining of yield limit is there. So that elastic limit also it is existing there. And these are all the things I'm just explaining here. And then organic farming we are conducting. And nowadays, people are fond of doing organic farming or natural farming. So different sources of organic matters, organic manures we have added, so that all the recommended dose of NPK we can get like that. All combinations we have prepared as a main treatment. A sub treatment you have taken in different biofertilizers, biocontrol agents, everything we have added there. And with that, with the application of poultry manure, with the base material, with the application of this all phosphate soluble bacteria, we got some higher yield when compared to the control. The 100% inorganic, where we got 28 kg per, that is a bunch weight, and this is the 27, more or less equal. And these are the mean values we have worked out. So like that, we have worked out all some combinations. And here we have to consider whenever we go for this organic manure application. So we are just thinking about the nutrient content in the organic manure, whether it is available form or not. That we have to see. So sometimes what happens, the nutrient releasing pattern of all the organic manures may not be exactly matching with the nutrient uptake pattern. So this matching has to be considered. The what all the nutrient releasing pattern of the organic manure should exactly match with the nutrient uptake pattern. That has to be done. So that also we have confirmed with the maximum performing variety, maximum performing treatment also we have done. So with this, some correlation studies also we have worked out where the poultry manure we have applied. So all this correlation coefficient what we got, we have worked out this nutrient content in the tissue soil content, and this is the nutrient in the leaf. So exactly it is matching on the fifth leaf stage. The soil nutrient is exactly supporting the 10 leaf stage, because 1 week ahead the soil should be prepared with the supply of nutrients exactly matching with the nutrient uptake pattern in the 10th leaf stage. So fifth leaf stage, the soil content is exactly supporting the 10 leaf stage. Like 10 leaf stage, the soil nutrient content is supporting 20 leaf stage leaf nutrient. So like that, some matching of releasing pattern and uptake pattern should be there. So that has to be considered. But most of the time, we are not bothering about the this character. Just we are dumping the organic manures, whether it is easily available form or not. Like that, we are doing. So like that, all the organic carbon content, the microbial properties, it is highly supportive where the nutrient content and which organic manure combination is supporting the microbial population also. Like that also we have conducted, and the organic carbon content different categories of carbon content also we have taken. So all our higher value we got with where we apply this poultry manure. Then soil amendments, problem soil. So you might have seen this saline sodic soil that marginal scorching is taking place. And this soil is not at all suitable for banana cultivation. But even then we can manage the soil so that we can get some economical yield. How we can do? So here we applied a trade with gypsum also. Then FIM, gypsum plus FIM, like that. So many trials which conducted, and mere application of gypsum is not sufficient. There proper drainage should be there. So that also be done. Everything we have considered, and with application of more potassium over and above the recommended one, we got better yield because potassium is having some mitigating effect over sodium, detrimental effect. So it is having some antagonistic effect over that. So that's why potassium is supporting banana growth in problem soil also. There we got some good application, and that salt injury also it is reduced where we got it, and the higher yield of 10.33 kg of bunch in Nendran we got with application of FIM and gypsum with under 20% more potassium application. So like that, some management practices also we have to do. So this coming under the dynamic of the soil. Here also we have conducted this QA parameters, and it is well supporting with the application of gypsum where the calcium content is there. If calcium content is there, the buffering capacity of potassium is improved. So that is another way. It is not at all only improving the salinity aspect, it also improves the buffering capacity. So that also we have studied. Then use of industrial waste, because this cement flow dust. So you might have seen chimneys of cement factory where we get our dense fume. Well, that is nothing but as a particle. That is flow dust. It is having more amount of potassium that we found it, and we used that for in banana cultivation. We got very good result. By that way, we can application of some half kg of cement flow dust per plant with a reduction of 40% of potassium application, we can get good yield. So by that way, also we can use this industrial waste for banana cultivation. We got a very good project. We got very good funding from DST. We got a very good result. So like that way, we can explore the potassium sources, because nowadays potassium is not available. I already mentioned. So we have to explore locally available potassium source that can be utilized for banana cultivation. So like this is the observation we got, and with application of cement kiln flue dust and distillery effluent with only 60% of recommended potassium, we got very good yield. So one way we can reduce the potassium consumption also. There's a microbial activities also. This is the bunch we got with application of flue dust. It is industrial waste only. But what we are thinking is it is not suitable for banana cultivation. It may be sometimes farmers not believing whether this type of dust it is applied, soil may be getting deteriorated. But it is not so. It is not happening there. We can utilize it properly. There also we have conducted this dynamic studies. It is very good support, because these are all the things justifying this treatment is performing good or not. This is the justification we are giving along with this buffering capacity studies. So these are all the observations, and these are all the another thing. This poly 4, another fertilizer is available nowadays. That is called polyhalides. That also we can utilize. There you can see where we applied this polyhalide. We got some ratio here, potassium calcium ratio. We got very good yield in that bunch, in that area. So we have to justify why this application of particular external source of nutrients is supporting, means we have to justify with these parameters. We have to work out the buffering capacity and this potassium to calcium magnesium ratio, and everything we have to justify. That's why I'm telling. Then use of domestic organic waste. Sometimes we have used this human urine also we have used for banana cultivation, because human urine, we have been knowing it is rich in nitrogen, but at the same time potassium also it is very rich in that. So with application of some these are all the treatments we have given in the eco toilet system in Musri area. There is one NGO that while defecation itself, solid waste and liquid waste, it is separated systematically, and that liquid that waste, that is urine collected, is utilized here along with a good quality of water we have given as a fertigation there. So per plant system, some 30 liters, 40 liters, 50 liters, 60 liters on control we have given. Then the main treatments like recommended dose of potassium, we reduce that potassium. By that way, we can reduce. This is a treatment design we have laid out. And 75% recommended K, 50 liters of urine is sufficient. Only 25% potassium we can save. But these are all the findings, but no takers are there. Social taboo is a barrier. Still, so far, this it is not adopted in the field itself, in the farming condition. But this result is there. But in future, at least it will be utilized. So then collector Mr. Soundaya, he only has collected harvested this first bunch. So like that, possibilities are there. But because human urine is a self-sterilizing substance, once it is collected in a closed container, within 5 days, within a week, all the bacterial population will be destroyed because of its salinity. So that salinity also we worked out, it is not affecting that one. So that much of good aspect is there, but nobody is taking this. Then integrated nutrient management, I already know this rice gas also we have utilized. Rice gas not only supplying the nutrient, but also improves the soil properties, soil physical properties. So by that way, that vegetative phase of the plant system, banana plant is improved, and yield we got very much with a reduction of some 20% of fertilizer NPK recommended one. Some only 80% is sufficient for that with application of rice gas. Like that we have found out, and with a different combination of biofertilizers also we tried, we got very good yield with rice gas, with phosphobacteria, that we got very good yield. And this is the bunch we got. So far we can reduce our input, the chemical fertilizers to maximum extent. We can supplement with organic source. That is the integrated farming system we got. And then micronutrient management, this is the thing everywhere I'm presenting. I'm just giving this. In case of micronutrient, what is the essentiality or role of micronutrient? Say, for example, if you take all the macronutrients as a big rock, it is unwantedly it is existing in your path. If you want to lift it, you are having crowbar, everything, but in the pivotal point, you have to put one small stone, no? Otherwise we cannot lift it. So that is micronutrient. That small stone, what you are putting, no? That is micronutrient. Without this absence of this small stone, we cannot lift this big rock. Then the soil pH given representing this length of the crowbar. If the soil pH is less than 3 or very low, the length of the crowbar is, we will not get the good leverage to lift it. So use efficiency will be reduced. If the length of the bar is more, say for example, this soil pH is more than 8.5, that the bar will be bending, but you will not get the leverage. But if the exact pH is there, with little pressure, you can lift. Even in the presence of all the micronutrients, if your soil pH is not supporting, the use efficiency of all the macronutrients will be affected. So this figure, always keep in mind, you can everywhere you go and you can tell it, you can simply explain to the farmers, they are just accepting that. So the role of micronutrient in the usage of macronutrient affecting with soil pH is very important. So this is the thing. And these are all the symptoms, summary of the symptoms, deficiency symptoms in banana. This nitrogen deficiency, this potassium, calcium deficiency, then magnesium deficiency, sulfur deficiency, iron deficiency, like that. All sorts of deficiency symptoms we got. And to rectify the micronutrient deficiencies, we have developed this micronutrient mixer. Because micronutrient deficiency comes means immediately application of single element, it is not sufficient. It is in the combination it should be. So based on our continuous research trial on 15 years of series of experiment, we have arrived at this ratio proportion of all the micronutrient. We have brought out with some micronutrient mixer. So it's called Banana Shakti. Then liquid formulation also we got, and this also it is released by our DDG. And then these are all the bunches you got, how happy they are getting using the micronutrient, because this is the simple thing. Micronutrient application will improve the quality and yield also. So then liquid banana Shakti, after that, now we are working for nano formulation. So nowadays, drone they are applying with the help of only application of 100 ml of nano formulation is sufficient for application of micronutrient banana. So that also we are coming out, and after that we are bringing out some tablet form also. We are just inserting the tablet in the pseudostem or in different locations wherever it is required. It is enough. There is no need of application or leaf as a spray. So like that we have trying, and these are all our modalities. And then this figure may be knowing the yield limiting factor. So your yield What all the other nutrients may be in the higher quantity, but certain nutrient will be in the lowermost level. This is called a limiting factor. Beyond that, you cannot improve the yield, even with the existence of other nutrients in the excess quantity. So this is the indication, and based on that, we have developed this DRIS concept based on the nutrient tissue concentration ratios. So because if you take the plant system, in the early stage, the concentration of any particular nutrient in the leaf will be very high. In the later stage, it as more production of the dry matter, it will be diluted, so low concentration. But the ratio between any two particular nutrient always remain constant throughout the system, throughout the duration of the crop. So that point we have taken in this, and we have developed the DRIS chart. And based on that, for a user-friendly package, we have developed this DRIS calculator also. Once if it is all the nutrients are estimated in the tissue samples, so which nutrient is a limiting factor we can identify, we can concentrate more on that so that we can rectify. Because banana is a long duration crop, then and then we can verify which nutrient is limiting and we can rectify immediately. So that is possible here, and that also we are doing. Then improved high density planting, because just we are applying the fertilizers, that nutrient use efficiency has to be improved. So that has to be seen. And this is the high density planting method. So it is a normal planting system we are adopting, 6 by 6. That is 1.8 meter by 1.8 meter in a Nandran variety or a Grandin variety. It is a normal planting system. For our convenience, just given in the black, red, and alternate this thing. And this is the normal system. By this way, we can accommodate some 1,200 plants per acre. If you see, if you take this red line, while planting itself, you are not going to plant, and that plant you are planting near the black row alternately. So you will be getting some wider space. So in that place, we can do some intercultivation, we can do intercropping. Even the drip line, lateral pipe also we can reduce. 50% of input cost also can be reduced. But at the same time, the population is maintained the same, because what all the left out one we have planted here. So while planting itself, just we are geometrically manipulating this one. And the next stage, what you are doing, the same population we are maintaining here. And next stage, another plant we are planting here. We are calling it as a hill, 3 plants per hill. By the way, the row to row distance will be 3.6 meter, and plant to plant within a row, it is 1.8 only. But population it is increased 50%, 1,800. Instead of 1,200, 1,800 it is coming. But here I am just asking one question. Per plant, it is requiring some 20 liters of water, means for 3 plants, how much water is requiring? 60, no? For this simple mathematical calculation. But practically, if you apply 40 liters of water for 3 plants, it is enough. For 2 plants, if you are applying nutrients, 1 plant is getting out free. So by that way, we can reduce the cost of input. 1/3 of the water or 1/3 of the nutrient can be reduced. At the same time, 50% population we can increase. So by that way, we can increase the yield, and input cost also we can reduce. So this is the method of improving the use efficiency of nutrient or input. So this is the thing. Just I want to share this, and this is the field view. And then paired row system also we are adopting. So simply not applying the fertilizer, we can manipulate the geometry of the planting system so that the nutrient use efficiency also can be improved. So that way we can sustain the soil health and soil fertility. So these are the future line of work and what we are adopting, and even we are concentrating more on silicon nutrition also, because silicon is banana is the silicon lover, silicon accumulator. Wherever the plant system accumulating more than 1% of silicon, it is called silicon accumulator. Banana is coming under silicon accumulator. That's why we are concentrating more on silicon also. Then potassium sulfate polyhalides also we are doing on different consultancy trials also we are conducting, and we are concentrating more on potassium. So these are all the things I just want to share with you. And this is the telling about dynamics between soil and the plant system. So any doubt is there, lateral we can clarify. Now we can thank you for it.
Hello.
Thank you, Dr. Jayabhaskaran, for your excellent and elaborate presentation on a particular subject, especially in banana crop. Normally, we always go for the soil aspect, but your particular crop soil, it's very difficult to narrate, but you have done a very good and you have justified your topic excellently. And only one question I want to ask, but our students may ask many questions, but I ask only one doubt I have. You said the 60:1, the banana pseudostem CN ratio, but you brought down to the 9:1 by using vermicompost. Have you added any external source of nitrogen?
No, we have only done with vermicomposting. So within 15 days, it is reduced. We have 2 or 3 times we verified with that, and it is drastically reduced because banana is a succulent system, plant system. So by that way, all the nitrogen is exhausted by the microbial population or this vermicomposting technology, and all the ratio is narrowed down to 9:1. We have not added any urea or a sprinkling of urea solution. We have not done, but even then we got very good result. So within 15 days, we can compost it with the help of vermicomposting. Immediately after composting that, we can apply to the soil.
Thank you.
It is an excellent presentation. Actually, you have covered almost everything about the potassium to banana. How can it partition towards the different parts, and also like a CN ratio was reduced from 60/1 to 9/1. And in one slide, you have given that total potassium applied is a 938 something kg. And 288 is a contribution towards the bunch. What is that, sir?
Actually,
900 and something in potassium applied, and 288 towards bunch. What is that 288? That is a kg or
yeah, that is a per plant if you have worked out.
per plant?
Per plant. That bar you have, no? Bar chart you have, no?
Not bar chart, sir. One total potassium highlighted 900 and something.
Yes, that much it is
uptake.
uptake
Okay.
per hectare. Per hectare it
Okay.
is.
Okay.
Sir, so I want clarification. Actually, in rice, during the maturity, the nutrient from flax leaf is going to grain, sir. Is it like that? Anything from bunch to banana? Is there any movement from after cutting the banana? After harvesting the banana, is there any nutrient movement from the petiole to bunch?
No,
Because-
no, it is a reverse movement is not taking place in banana system.
Hmm.
Because in most of the time, they are recommending tying of urea or potassium sulfate in the distal end of the bunch, but it's not performing well actually. Because source to sink and sink to source, that ratio, that flow is not perfectly, it is taken place. Source to sinks only it is going on there. But only with the application of potassium sulfate, it is performing good for bunch development and everything. Because potassium is not at all, it is mingled in the tissue system. But the presence of potassium is very much essential for translocation of a carbohydrate accumulated in the corm for translocating to the bunch. Potassium is very essential. But potassium is not taking part in any part of any system or any tissue system. But it is remaining as such. It is a catalyst type. It is a peculiar nature of the potassium.
Students, any questions or any clarifications one from the chairman of the session?
I'm Kaushika from crop physiology. Sir, we know for cereals and other crops, usually the flag leaf contributes for the panicle development or the earhead, whatever it is. And in case of banana, which there will be 20 to 25 leaf, maybe more than that also. So which leaf contribute for the bunch development, or how many optimum leaf is required for bunch development?
Okay. Okay, for number of leaves you are asking, no?
Which leaf is contributing?
That fully opened third leaf. Fully opened third leaf, we have to take analysis. At any stage of the crop, the fully opened third leaf. One leaf roll will be there. That we should not consider. And below that, third leaf we have to take. From top to bottom. Third leaf.
No, not for analysis, I am asking. Which leaf contributed for bunch development, for banana development time?
Definitely, this is flag leaf only.
Only,
Flag leaf is very important.
okay.
If it is removed, definitely the bunch development, bunch quality will be deteriorated. Because this flag leaf also very supportive for the peduncle covering. Sometimes what happens, the bunch will be there in the peak summer season, sun scorching will be taking place on the peduncle. Once if it is getting affected means secondary infection with the bacterial or fungus growth will be there. Bunch development will be restricted there. Because that peduncle is very important bridge between the plant system and the bunch. The translocation of carbohydrates is taking place there. So for protecting that also, that flag leaf is kept over that and it is tied with it. So that flag leaf is very important. If you cut the flag leaf, definitely yield will be reduced by 50%. It's very important.
We are fortunate to listen your inspiring words and experiences with us today, sir. Thank you so much. Now, let's have a refreshment and kindly assemble within 10 minutes. We will start the oral presentation session in few minutes. All the oral presenters are requested to occupy the front row after refreshment, and attendance will be marked after completing the oral presentation. I repeat, attendance will be marked after completing the oral presentation. Refreshments are arranged outside the hall.
Converting wood ash into a nanosilica, so using the sol gel method. So to alleviate this chromium stress, we are using nanosilica as a seed priming agent for maize crop. So with this small introduction, I will go through my objectives. My first objective is synthesis and characterization of wood ash derived nanosilica. First, we have done the characterization of wood ash. So in this wood ash, we are seeing the same images, which shows a different spherical shape and irregular shapes, and the edox of the wood ash, it shows 1.9% of silica. So with this primary data, we have moved to synthesis of wood ash, nanosilica synthesis from wood ash. So in this, the first image which shows the wood ash which is generated from tea factory. So we are successfully converting the wood ash into silica using the sol gel technique. So this step, first it starts with the leaching of metal impurities from wood ash. So in this metal impurities, we are using HCl for leaching the wood ash, and then laboratory preparation of nanosilica solution, followed by precipitation of nanosilica from alkoxide precursors. So in this, the characterization of synthesized nanosilica. So first, the zeta potential, it shows minus 35.8 millivolt, and followed by the size range is around 25 to 50 nanometer. So the X-ray diffractometer, it shows the crystalline nature. The UV spectra, that the absorption peak is obtained at 258 millivolt for nanosilica, and the FTIR images, it shows the functional groups of silica and other functional groups like OH bond, remaining things, and the TEM images, it shows the spherical nature of silica with before synthesis nanosilica. So from wood ash, we are seeing the images around 13.4 micrometer. So after synthesizing nanosilica, we are successfully bring the image size reduced to below 10 nanometer. And with this characterization result, we further moved into the germination study, which was conducted in Department of Environmental Study Sciences. So in this, we are used the maize seed as a co-hybrid 8. So in this, we are used a factorial CRD design with two factors. The factor number 1 is a silica with 0 to 500 ppm concentration, and the factor number 2 is a chromium concentration. So in this, we are used the hexavalent chromium. The reason why we have used this hexavalent chromium and instead of trivalent chromium, the accumulation which is once the chromium hexavalent is entered into the root system, it is turned to, when it is oxidized, and it is turned to trivalent chromium. So in this we are used hexavalent chromium because the mobility is very high and the water solubility nature is also very high for hexavalent chromium, and the oxidizing state is which further induce the oxidative stress in the plants. So in order to mimic the environmental conditions and also the other parameters, we are used a hexavalent chromium as important one. And the first one, we have seen the germination percentage. The germination percentage, which shows in the silica concentration 200 ppm, the T24th treatment. This treatment, which have 100 ppm chromium concentration, it shows good germination percentage at 99.3%, followed by root length and shoot length. So it shows in T24th treatment. So this is the chromium concentration in both shoot and root concentration. So in shoot concentration, the T20th treatment. So in this treatment, so we are priming the seed, silica maize seed with 200 ppm silica concentration, and the T23 treatment is 600 ppm of chromium concentration. So in this treatment, we showed heavy accumulation of chromium concentration. So the bioavailability, which is in root and shoot, the bioavailability in root is a 1.250 ppm, and in the shoot concentration it is around 1.85 ppm. So it shows that the effective that silica, it acts as a protective barrier for entry of this chromium ions into the root and also the shoot system. So then I move to the third objective, that is the in silico perspective of seed priming of nanosilica on the phytotoxicity and accumulation study. That is a pattern of chromium which is seen in the maize seedlings. So in this, we are chosen four different types of proteins, that is catalase, superoxide dismutase, glutathione reductase, and glutathione peroxidase. With the two ligands we have used, one is the ligand number 1 is chromium 6 and the ligand number 2 is a silica nanoparticle. So in this C-Docker interaction, in the C-Docker interaction energy, for catalase it shows a higher interaction. So in which means the binding sites is very high, and for the second superoxide dismutase it shows a lower interaction. So these are some of the docking results. So with this, I conclude my presentation. So in this, the research findings, it shows that at 200 ppm concentration of silica, it shows good protective results. And this further we are suggesting as to improve the maize yield and also the quality of chromium contaminated sites. And the mechanism which is behind this, when we are suggesting to large scale studies, so it will be reduced oxidation stress and enhanced nutrient efficiency and improved water use efficiency, and it stimulates the antioxidant enzymes. And in the docking, the result shows that the both wood ash derived nanosilica and chromium 6, it effectively modulate the redox homeostasis by limiting the ROS production, and therefore it confers against the oxidative stresses. Thank you for giving this opportunity. Ma'am, 13.2 micrometer in wood ash, ma'am. So after synthesizing silica from wood ash, then we are bring the TEM images. It shows below 10 nanometer, and the particle size in analysis, which shows the approximate range is 25 to 50 nanometer range, ma'am. Yes, ma'am. Ma'am, it is observed that in tannary contaminated soils, so the maximum in soil it is around 250 ppm. It is a previous report from our department, and in some millet studies, like the maximum accumulation is around 240 ppm concentration. So in this, we have chosen up to higher concentration, up to 600 ppm. We have chosen for this study. Yes, ma'am.
What is the exact mechanism of action of silica?
Ma'am, silica, it is one of mainly it can easily, due to the size range, it can easily enter into the root system and also the shoot system, ma'am. And the second thing, nature of the silica particle, it acts as an antioxidant. It have both antioxidant property. So when we are applied in large scale studies, it can able to improve the nutrient status of the soil in addition to alleviating the stress. So it is also confirmed in other types of abiotic stresses like drought, heat, and freezing type of stresses in other type of studies, ma'am.
Silica is it itself act as an antioxidant.
Yes, ma'am.
or
The
it
silica nature
stimulates
of this.
the other
No, ma'am.
antioxidant?
The silica itself has an antioxidant property.
So what is the advantage of nano form of silica? Instead of that, can we use any normal silicon element for
Sir,
this?
for this study, we are didn't go for comparative analysis, but in my case, when we are going for silica, the other type of results which we are coming across, so the effect it will be very low because when the size which is for seed priming, the seed cotyledons and seed meniscus, it will be in the nano range. So once we are using nano silica, it can easily able to penetrate into the seeds when compared to normal silica. So the germination percentage, it will be very high in nano silica when compared to silica commercially available or mainly silica content.
Okay, if a farmer want to adopt this type of technology, so how best it can be utilized? Because a nano formulation of silica may not be available to him. How he can manage with it?
Sir, when we are seeing other types of studies, when I was coming up across the literature survey, so the thing is that like uh, we can say it is best like in
How the farmers can utilize this type of strategy?
sir, yes, sir. If we take a rice husk related type of silica deriving from that, so the silica content is very high, around 98% of silica we can obtain. So we can easily convert the waste into silica. So we don't want to silica eliminate this type of ash into the landfill type. So we can effectively utilize this silica, and the chemical approach for synthesizing waste to silica is very good when compared to other type of synthesis. So silica is easily able to adapt when compared to other types of.
Okay, okay. Why I'm asking this? Because it should be easily adaptable.
Yes, sir.
Any
So
technology
in
or any
Colgel
strategy.
technique, it is the quantum yield. The yield of silica is very high when compared to other type of silica content. So I think this will be a best solution for adapting to large scale studies.
Okay.
Silica.
Sir, from first we are seeing the wood ash. The wood ash percentage of silica is 1.9 percentage. So with that, we are moved to sol gel techniques. So in that sol gel technique, we have optimized different factors and we have synthesis.
1 minute. Have you extracted the silica from the hull ash?
Sir, we are extracted from wood ash.
No, you have extracted silica from the wood ash.
Yes, sir.
How did you? What is the method of extracting the silica from wood ash?
First, we are gone for leaching. Sir. First, we are removed the impurities from wood ash. Then we are gone for precipitation with help of alkali precursor.
Okay,
We are
okay. Thank you.
Thank you. Next presentation is S. Ajmal Siddiq presenting the effect of plant growth regulators on green gram under salinity stress.
Good evening to one all. Myself is Ajmal Siddiq. Now I am going to present about the effect of plant growth regulator on green gram coat under the salinity stress. This is a small introduction. Green gram is a Vigna radiculata. It is a pulse crop from the botanical family Fabaceae. According to the many report, the 6% of the world lands is affected by salinity. And the major constraints in the crop production is under the salinity stress only. The higher concentration of the salt in a soil that will affect the plant to ability to uptake and hold the waters in your roots, which will affect the germination of the plant. This salinity stress can be overcome by plant growth regulators like NAA from Maxine, cytokinin, gibberellin. This present study was to formulate to standardization of NaCl and to study the effect of plant growth regulators on the salinity stress during the germination, seed germination. Objectives. The standardization of NaCl to study the effect of salinity during the seed germination. Study of the response of plant growth regulators to salinity during the seed germination. Experimental details. In this experiment, we used a CRD, completely randomized design. The experiment was completely done in the laboratory techniques. This experiment is conducted in 8 treatments and 3 replications. Green grub, co-8 varieties. First is standardization of NaCl. This green gram seeds are treated with a different concentration of NaCl 75, 100, and 150 and 200 mm. In that 50 and 75 has a full germination, and the 200 has a poor no germination, and 150 has a 50% of germination. So we taken as a 150 as a 150 concentration, and we proceed the experiment. Treatment details. Treatment 1, using of the distilled water. Treatment 2, using of standardization of NaCl. Treatment 3, NaA 100 ppm. Treatment 4, NaA 200 ppm. Treatment 5, kinetin 50 ppm. And treatment 6, kinetin 100 ppm. Treatment 7, gibberellin 100 ppm and 200 ppm. First, we soak the seeds with the plant growth regulators for 12 hours, and they shade dry it and place it in a petri dish separately, and pour the 100 ml of standardized NaCl, which is 150 mm. Once 3 days, we pour the 100 ml of NaCl. For absolute control, we maintain the distilled water. Result and discussion. In that, we see here 5 parameters. One is germination percentage. In the germination percentage, 79.68%. Highest germination percentage of 79.68% observed in a T8, followed by treatment 7. For shoot length, 17.3%, followed by treatment 7, 15.5%. In root length, highest root length is observed as treatment 8, 6.4 centimeter, followed by treatment 7, 4.52 centimeter. In vigor index, highest vigor index in treatment 8, 1745, followed by treatment number 7 and 6. Dry matter production, treatment 8 has a highest dry matter production of 0.25 gram, followed by treatment 7, 0.21 gram. Conclusion summary. We found out that the effect of salinity on green gram and studied about the effect of plant growth regulators in responding to the salinity stress. First, we standardize NaCl at 150 mm concentration. It shows a 50% of the germination, and we proceed our study. Among those various plant growth regulators, gibberellin 200 ppm has a better result in all the parameters like germination percentage, shoot length, root length, vigor index, and dry matter production when compared to all. The reason behind this was the GA3 has a induced expression of stress responding gene that will help the plants to cope up with salinity. This inducing gene will induce the ion transport, osmotic adjustment, and the anti-accident defensive mechanism, which will collectively improve the plant growth and the germination. Thank you.
Thank you. Judges, please note the time. 5 minutes, 51 seconds.
Okay, who is your chairman, Pa?
I'm Ramesh, sir, ma'am. Ramesh Saturchi.
Trichy, yeah.
Yes, ma'am. Actually, this study was conducted in a UG, ma'am.
Okay.
When I was studying in UG, ma'am.
So, இது வந்து
UG
project,
project, ma'am.
So you have used 150 millimolar sodium chloride.
Yes, ma'am.
So how much easy that?
ECM.
அதுவே தெரியாம பண்ணீங்களா?
பண்ணோம் சார்.
150 millimolar sodium chloride is equal to how much EC? சொல்லுங்க ஸ்டூடெண்ட்ஸ். யாருக்கு தெரியும் சொல்லுங்க. Anyone? From soil science? The 15 EC.
15 is.
நம்ம maximum we can use only 12 EC for experimental purpose. But you have used 150 millimolar of sodium chloride.
மேம் ஆல்ரெடி ஒன்று எக்ஸ்பெரிமெண்ட்ல யூஸ் பண்ணியிருந்தாங்க மேம் 150. அதை வச்சு நம்ம பேஸ் வச்சு நம்ம யூஸ் பண்ணியிருந்தோம்.
Okay, you have used GA 200 ppm.
எஸ் மேம்.
So what is the mechanism of action behind that? How it can improve the germination?
Ma'am, GA has a ability to seed germination, ma'am.
You don't worry about the genes. What is the physiological mechanism?
Physiological mechanism.
படிச்சிருக்கீங்கல்ல?
Yes, ma'am. GA3 has
seed germination ல என்ன பண்ணும்?
GA3 வந்து ஸ்டிமுலேட் பண்ணும், growth ஸ்டிமுலேட்
என்ன
பண்ணும்.
ஸ்டிமுலேட் பண்ணும்? ஆல்பா அமிலேஸ்.
Yes, ma'am.
அதெல்லாம் சொல்லணும்ல? Okay, all the best.
How did you prepare this 150 millimolar sodium chloride?
Sir, 150 millimolar molecular weight into molarity into molecular weight into molarity into volume divided by 1000, sir.
What is the how will you prepare? எவ்வளவு quantity of sodium chloride எடுத்தீங்க? எவ்வளவு லிட்டர் தண்ணியில கரைச்சீங்க? To bring into 150 millimolar solution.
0.85 gram.
gram in
100 ml of water, sir.
That is equal to?
That is equal to 150 millimolar, sir.
When presenting a graph or anything, you just spell out the short name of the treatments, not
Okay.
the T1, T8. Like.
Okay, sir.
Okay.
Thank you. Next presentation, N. Satyabama presenting Cultivating a Greener Tomorrow, Harnessing Fodder Cultivation to Sequester Atmospheric Carbon and Propel Global Warming Mitigation.
Good afternoon to everyone. And now I am going to present my oral presentation on cultivating greener tomorrow, harnessing fodder cultivation to sequester atmospheric carbon and propel global warming mitigation. Coming to introduction. The yearly increase of atmospheric CO2 was approximately 0.8 ppm in 1960s, whereas it was raised up to 2.13 ppm in 2021 and 22. It is ultimately leads to increasing in the global mean temperature. So among the different approaches to mitigate climate change, agriculture plays a major role. It will especially croplands and grazing land store up to 8.6 gigatons of CO2 per year. Among the different agricultural crops, particularly forage crops store more carbon because of its higher rhizodeposition and higher biomass. It will help to more carbon sequestration, and further it can be achieved by managing soil management practices, wise biofertilizer application and manure managements. Background of my study is assessment of inorganic, organics and biofertilizer and soil carbon balance in combinapier field, and assessment of inorganics, organics and biofertilizer and CO2 emission and carbon sequestration and global warming potential of combinapier field. And this is my This is my treatment details, and I followed a randomized block design and with 3 replication and 11 treatments. First one is recommended dose of fertilizer and soil test based recommendation, and T2 plus soil test based recommendation along with arbuscular mycorrhiza, and another treatment is with asophos, and another treatment with both asophos and arbuscular mycorrhiza, and another treatment is with reducing 25% of nitrogen with asophos and arbuscular mycorrhiza, and another one is FIM 100% and poultry manure as such 100%, and T9 is reducing by 25% of nitrogen equivalent basis along with arbuscular mycorrhiza and asophos, and finally absolute control. Coming to the impact of inorganics, organics, and biofertilizers on soil carbon balance in combinapier field. This one, first one is total organic carbon. In that, highest amount was recorded in T10 treatment, which is received by 75% N equivalent basis poultry manure along with biofertilizers. And coming to the water soluble carbon was higher in T9, which is FIM received a treatment, and KM1 also for oxidizable carbon was higher in TA treatment, poultry manure at 100% without application of biofertilizer. Here we are working some carbon balance. The passive carbon was calculated by minusing TOC with active pools such as water soluble and KM1 for oxidizable, and that was converted into the percentage, and from that the percent soil carbon stock was estimated with the percent percent permanent soil carbon stock into depth and bulk density, and finally added soil organic carbon in passive carbon pool was worked out based on each treatment permanent soil carbon stock minus the initial soil sample were estimated. In this, overall the the passive pool carbon was higher in the T10 treatment, which is received with poultry manure 75% N equivalent basis along with biofertilizers. Application. Coming to the impact of inorganic, organics, and biofertilizer on total CO2 emission, carbon sequestration, and global warming potential in terms of tons per hectare per year of combinapier field. Here the total CO2 emission was higher in FIM at 75% N equivalent basis along with asophos and AM received treatment, and the total CO2 sequestrated by the total biomass was higher in T10 treatment, which is poultry manure at 75% nitrogen, and along with asophos and arbuscular mycorrhiza. And finally, the global warming potential was calculated by minusing the CO2 sequestered by the total biomass into total CO2 emission. In that, the lower global warming potential was observed in T10 treatment, and the higher was observed in the absolute control treatment. And coming to the impact of organic, inorganic, and biofertilizers on carbon stock in terms of tons per hectare per year of combinapier field, here the T10 has the more carbon stock when compared to other treatments. Coming to the conclusion, among the 11 different treatments, the application of poultry manure at 75% nitrogen equivalent basis along with asophos and arbuscular mycorrhiza treatments will help to increase the fodder yield, nutrient, and soil quality. Subsequently, it will also help to mitigate the climate change through soil carbon sequestration and reducing the important greenhouse gases. Thank you.
You. Time taken for presentation is 6 minutes 16 seconds. It's open for discussion.
Sir, it has more amount of less labile carbon, sir. it has more amount of less level carbon. That is, it was stored more amount in passive pools when compared to active pools. For that only, it will store more amount of carbon when compared to other treatments.
About the recalcitrant carbon.
Recalcitrant carbon amount is more in poultry manure, ma'am, when compared to farmyard manure and other things. For that only, it plays a major role in carbon sequestration when compared to other treatments. We are working on recalcitrant carbon also. I am not mentioning. Just I'm minusing with the active carbon pools with the total carbons, total organic carbon, I will get some passive pool of carbons like that. I am working.
Okay, what is the role of AM on carbon sequestration, ma?
That fungi will helps to improve the soil structure by means micro aggregates and macro aggregates will be more, by which means it will hold more amount of carbon and nutrient and other things. By holding and releasing nutrient, it will increase the biomass of the crop. That biomass will help to improve the carbon sequestration in the field.
So how do you estimate the carbon dioxide release?
Sir, I'm estimating with the help of GCMS analysis, sir. GCMS with by means of closed chamber method. I'm not mentioning here because of time comes. Closed chamber in the field, I am fixed some closed chamber, sir. It contains some exhaust fan and septum, sir. In the by which means the flux values are collected, gas samples are collected, and that is given to the GCMS analysis. From that, I am getting data, and I am accumulated all the data and combined and given a CO2 emission.
Okay. In a set of treatment, how many times you are randomized in that actually for collecting that?
Sir?
Randomization.
Three,
How many times?
Three times, sir.
3 times.
Three.
It's a replication you have taken.
A replication value, sir. It is cumulative data, sir. Cumulative data of 1 year. CO2 emission data is cumulative data 1 year. Certain time intervals I am taking samples and I am analysis as the whole I am cumulated and presented here, sir.
Okay, because this same type of observation we also got with application of poultry manure. That recalcitrant carbon content is very high in that actually. Because immediately it is coming and that compactness of the soil is also it is improved and it is very good actually. So the similar kind of observation we got in our research also.
Okay, thank you, sir. Sequestrated carbon by estimating the biomass, biomass of the crop, sir. Oh. Sir. Added biome, which means below ground biomass will be added to the soil, sir. So below ground portion of the part dry combustion method, we are estimated the carbon from that CO2 converted into the CO2 and presented here.
Have you analyzed organic carbon by Walkley and Black method?
Yes, sir.
How many samples you analyzed in your experiment?
Sir, nearly I'm having 3 more crops, sir.
I am asking how many number of samples, soil samples you analyzed for soil organic carbon? By Walkley and Black method.
Nearly more than 200 to 300.
How will you prepare potassium dichromate solution?
Sir,
what is the normality of potassium dichromate used for extraction?
One normal, sir.
How did you prepare that?
37 grams in 1 liter of water.
How much gram dissolved in 1 liter?
37 grams dissolved in 1 liter.
How you fixed 37 gram? How did you fix 37 gram? Why not 40 gram?
Sir, KMN for normal, for preparing normal solution, equivalent weight of the substance in 1 liter will use 1 normal solution. So equivalent weight of potassium KMN for receive.
Will you follow equivalent weight for preparing the normal solution in potassium dichromate?
No, sir. That one is a oxidizing agent, sir. So
How much nascent oxygen is released?
6.
Very good.
Questions from students?
Thank you, sir. Thank you.
Thank you. Next presenter is Bekam Rakesh, presenting maximizing silicon release and stress tolerance in hybrid maize by nanosilica synthesized from rice husk.
Good evening, everyone. Respected chair, co-chair, myself Bekam Rakesh. I am going to present on maximizing the silicon release and stress tolerance in hybrid maize by nanosilica synthesized from rice husk. And this is the graphical abstract of entire events of the study. First, we have prepared nanosilica by using rice husk as a precursor, and by optimizing the various steps like calcination, alkali extraction, and we have synthesized nanosilica, and followed by we have evaluated the release characteristics through an incubation experiment and followed by a pot experiment. And coming to the introduction of the topic, due to the changing climatic conditions, there were so many environmental stresses were imposed. In that, the drought stress is the major stress which hampers the crop productivity. Hence, the technologies must be searched for improving this drought stress tolerance. Among them, the silicon is one of the element which having the fascinating roles in regulating the drought stress. Due to its fascinating roles in mitigating the drought stress, it is called as a quasi-essential nutrient. And furthermore, there are so many commercial silicon fertilizers which having unknown silicon percentage, and the silicon release was also not clear. Hence, we we are going for the nanosilica. Here in nanosilica also there are the two methods. First one is the chemical method, and next one is using the green precursor. In chemical method like tetraethyl orthosilicate, if we use TEOS, it might be not economical and it might be costly and uh, involves toxic chemicals. Hence, we have used the rice husk derived rice husk as a precursor for the nanosilica synthesis. And this is the materials and methods we have followed. And in our previous investigation, we have evaluated the silicon percentage from the various agricultural bases, which was published previously, and by using the modified soil gel method. And we have conducted an incubation experiment with the various levels to know the silicon release pattern in the soil. And whereas we also conducted the pot culture experiment. In this, we already have screened silicon efficient genotypes, that is CoHM8, which was published in the Silicon Journal. And for this experiment, we have induced the drought stress by maintaining 50 plus or minus 5 field capacity by using ML2 theta probe moisture meter. And all the soil and plant analysis was done as per the standard protocols. And coming to the characterization of the synthesized product, here we have characterized for using various equipments. The SEM analysis showed that synthesized particles having the spherical morphology with silicon and oxygen as the major elements, which was proven in the IDAX, and showing the slight exuberation as shown in the TEM, having the siloxane bonds at 1090, which is a characteristic peak for silicon molecules. And in XRD, the peak at 22 degrees indicates the synthesized product is having the amorphous nature with a good stability as indicated in the zeta potential. And coming to the incubation study, we have seen the pH, EC, and available silicon. The pH was decreased with increasing the levels of the silica, which might be due to the formation of the monosilicic acid, which is a neutral molecules, and the pH tends to be neutral. And the pH and EC were found to be non-significant. Whereas available silicon, with increase in the silicon levels, silicon content in the soil was increased up to 60 days, and later 80 days due to formation of the and due to lessen the availability of monosilicic acid, it was decreased. And later, this available silica was fitted in the various kinetic models to know the mechanism behind the silicon release. That is zero order, first order, second order, simple Elovich, parabolic diffusion, power function, and pseudo second order. Among them, pseudo second order model is having the highest R-square value. Hence, we concluded that the mechanism behind the silicon release is the chemist option. Here we have analyzed the various rate constant for the pseudo second order model. Equilibrium constant QE is increasing with increasing levels, whereas release rate was increasing with the increasing level. Whereas further we have conducted the pot experiment. In pot experiment, we have shown that it was proven that application of 20 milligram per kg and 30 milligram per kg in irrigated and drought conditions respectively has increased the total biomass and total chlorophyll content. This might be due to increase in the photosynthetic rate, and this nanosilica has efficient role in increasing the ribulose 1,5 bisphosphatase, thereby increasing the photosynthetic rate. And one more thing is silicon also maintains the structural integrity, which makes the leaf to stand upright and reflects the solar radiation, and hence resulted in higher photosynthetic rate. And with increasing the nanosilica level, silicon content also increased. Whereas superoxide dismutase and peroxidase was increased up to a certain limit. Later it was declined because higher silicon content also causes destruction of the stomatal structure due to its thickened cuticle, and hence ROS was increased, thereby superoxide dismutase and peroxidase activity was decreased at the higher concentrations, and followed by relative water content. With application of the silicon, the relative water content was increased with increasing levels, which might be due to the activation of aquaporins and increasing the root hydraulic conductivity and xylem loading of the water, and followed by electrolytic leakage. Silicon has a major role in improving the membrane stability by forming the thick silicon cuticle double layer, thereby decreases the electrolyte leakage, and it also decreases the proline content under under stress conditions, because this nanosilicon is also helps in converting these proline molecules into the silaproline molecules. That's why proline content was reduced under drought stress. And further, these studies was confirmed in Pearson's correlation and PCA blipot. There all the cluster indicates that those parameters are having the highest correlation, whereas oppositely in MDA content, ELA and proline content on the opposite side indicates having the negative influence. And here the red color indicates the positive influence, and blue color indicates the negative influence. And conclusions: this nanosilica synthesized from rices has the spherical morphology, amorphous structure, siloxane bonding at higher purity. An incubation experiment revealed that increasing levels has increased the available silicon content in the soil, whereas pot experiment shows that optimum response with 20 milligram per kg and 30 milligram per kg in drought and stress conditions. And finally, I would like to order the Department of Soil Science and Agricultural Chemistry, DST Inspire, for providing the fellowship.
Thank you. Time taken for presentation is 7 minutes, 11 seconds. Open for discussion.
Students also should interact. Then only the mark will be evaluated based on the interaction with the students' questions. That is more important rather than the judges' questions. Okay. That is also there, right?
So you have conducted the incubation experiment, no?
Yes, madam.
On which stage the silica release was high?
Madam, at 60 days silicon release was high, madam. Later, this monosilicic acid may be turned into the amorphous form, madam. That's why it was declined at the 80 days.
At 80 days.
At 80 days, it was declined, madam.
That's what you have restricted up to 45 days in pot experiment.
Pot experiment we have restricted up to, according to maize physiology, till 60 days maize will have the capability of taking silicon, madam. 60 to 80 days. Pot experiment maize we cannot grow beyond 45 days, madam, because that much stature will not come in the pot. That's why we restricted up to 45 days. We have concentrated only on the mechanisms, madam.
Of nanosilica, what is that level?
Madam, 22 in silicon raise was very less only, madam. 22.7. We have conducted experiment in low silicon soils, madam. That is 22.7, and it was raised to 25, madam. That's all.
You are synthesizing from rice husk. On previous paper, we have observed that they are synthesized from wood.
Sir,
And
actually,
which one will be the better, or what is the
sir,
significance?
actually, we didn't synthesize it from only rice husks, sir. We have chosen 8 residues, sir. That was published already. Madam, when we calculated economics, it will be around 450, madam, with rice husk. But if we produce in the large scale, it may be reduced, madam. But actually, we have evaluated around 8 sources, madam. Among them, based on the recovery and based on purity, we have selected rice husk as a source, madam. Other sources like paddy straw, sugarcane, bagasse.
Okay, you have done very good presentation. Regarding this, we have talking about other this thing only. But what is the interaction of silicon with the phosphorus?
Sir, it
Have you
is a
studied that because the silicic acid may be having a synergistic effect over
Yes, sir.
phosphorus.
Yes.
So it may be some of the reason may be there.
Yes, sir.
Better effect of that.
Yes, sir. There are two types of mechanisms, sir. One in case of phosphorus deficiency and one in case of phosphorus toxicity, sir. Whereas in phosphorus deficiency, it will increase the phosphorus availability in the soil, sir. Whereas in case of phosphorus toxicity, it will complex all the phosphorus in the root itself, and it prevents its translocation to the shoot, sir. And it also regulates the apoplastic silicon major role. It will regulate the apoplastic pH also, sir.
You meant to tell that silicon is complexing the phosphorus in the root zone.
No, sir. It not a compensation, sir. It improves the use efficiency of phosphorus, sir. It cannot completely mitigates the deficiency symptoms caused by potassium, sir. Not even nitrogen also, but it improves the use efficiency.
Use efficiency.
Use efficiency, sir.
Published article in silicon. What is the NAS rating?
Now it is 9.8, sir.
Okay.
But due to change in impact factor, this year on July 1st, it was.
Have you analyzed silicon in soil?
Yes, sir.
How many samples you analyzed?
150 samples I have analyzed.
What is the procedure you followed for silicon analysis?
Ammonium acetate method, sir, given by Narayanasamy and NB Prakash et al. 2009.
What is the container used for silicon analysis?
Polypropylene bottles, sir. Polypropylene bottles.
For all things you have used polypropylene?
Sir.
For everything?
Everything.
Extraction.
From extraction to last we have used.
What is the color you developed?
Blue color, sir.
Very good.
Thank you.
I not only Rakesh, every student, every presenters have done well. Everybody has presented very excellently, but the mark will be different only just small minor mistakes only. But don't think that he has said very good presentation. We said he is very good. Others is not present. It's not like that. Every guy presented very well, but only the difference is only minor only. It will be there because we have to evolve it, right? Okay.
Next presenter is D. Ritika, presenting groundwater quality delineation in Tiruvallur district, edges-based approach.
Good evening, everyone. I'm going to present on the topic groundwater quality delineation in Tiruvallur district, a GIS-based approach. Next. Tiruvallur district, it is the northernmost coastal district of Tamil Nadu, and it is bounded by Bay of Bengal in the east, and Vellore district of Tamil Nadu, and Chittoor district of Andhra Pradesh in the north, and Kanchipuram district in the south. It consists of 14 blocks, 526 villages, and 3,842 habitations. The main objectives are survey and collection of groundwater samples using the GPS, and characterization of the groundwater samples using CSSRI water quality classification, and ionic ratios and other parameters were assessed to assess the seawater intrusion, and a thematic map was prepared using the AGSC software. The methodology: for every 10 square kilometer, the groundwater samples were collected and it was characterized based on the kernel water quality classification, and ionic ratios were used to screen the groundwater samples for seawater intrusion, and a thematic map was prepared. The collection of samples at various blocks. This is the CSSRI criteria for groundwater quality, and it will be classified as saline or alkali or toxic water. AGSC software, it is a geospatial software which is used to view, edit, and analyze the geographical data In this mapping software, the block borders were digitalized and all the data were entered. After that, the thematic classes were prepared and the thematic map was prepared using this software. For 14 blocks, the mapping was done. And next one, to identify the seawater intrusion areas, 4 parameters were seen: ionic ratios, seawater mixing index, inorganic charge balance, Piper plot, and the water quality index. Coming to the ionic ratio, if the chloride by bicarbonate ion is more than 1, it indicates a seawater intrusion. Seawater mixing index, it was more than 1. And next one is the inorganic charge balance. While coming to that, we found that 33% was net negative charge and 67 was net positive charge. And it indicates that there were more cations than anions. This is the Piper plot diagram. Actually, it is an approach which is used to study the chemistry of the groundwater samples. Here, it consists of 3 parts. First one is the diamond part. It consists of both cations and anions. The bottom left, it represents the cations. The bottom right represents the anions. So it represents the center diamond. When coming to the diamond plot, the top quadrant, it consists of calcium sulfate, and the left quadrant is calcium carbonate, and the right quadrant is sodium chloride, and the bottom quadrant is sodium bicarbonate. And we have found that majority of the sample falls under domain 2, that is the sodium chloride combination, and it indicates the possibility of seawater intrusion. And this is the finalized data. And while coming, we came to know that 41% of the samples fall under marginally alkali water, 34% under good quality water, and 23 under alkali, and 2% under saline. The main conclusion is most of the dominating ions were sodium and bicarbonate. And here we can find that the problem is alkalinity, marginally alkaline, because of the dominance of sodium and bicarbonate ions. And the recommendation what we have given is gypsum, it can be used as an amendment for both the irrigation water and soil. And also ADR approach can be used. That is the abstraction, desalination and recharge approach. It means abstraction of the brackish water from the saline water zone, and next desalination of that abstracted water. And next one, recharge is recharge of the treated water into the aquifer. By these 2 ways, we can prevent these marginally alkalinity. Thank you. Thank you, sir.
Thank you. Time taken for the presentation is 4 minutes, 30 seconds.
Okay. From your presentation, what is the final recommendation what you are going to give to the farming community in that area?
Sir,
Any ready reckoner you have developed out of this?
Sir?
Ready reckoner or any recommendations to the farming community?
Sir, yes, sir. That only gypsum, sir.
Okay, gypsum application, if any drainage problem is there.
Yes, sir.
In that case, how the gypsum will work out?
Sir, if any drainage problem is there, first after analyzing and how to by some that only, sir, using this ADR approach, we have to first try to make that water clean, and after that try to overcome this gypsum method.
Because of the sodicity only you are telling, no?
Yes, sir.
I have one small doubt, ka. While preparing thematic maps, whether you have used interpolation techniques?
Yeah, we had from AGSC, that is a software 10.1, and there many boxes will be there, many catalog boxes, AGSC toolbox, AGSC catalog, and using all these things, interpolation techniques also were used, and we have done that mapping.
Whether you used kriging method or inverse distance swaying method?
Inverse distance.
Why have chosen inverse distance swaying instead of kriging method?
We can get we can differentiate whether which one is good or which one is marginally alkaline.
Good evening, one and all. Today I am going to present my PG research on predicting soil texture using machine learning algorithm. First, soil texture is relative proportions of sand, silt, and clay, and it is the basic property. It will decides and facilitates the water flow and neutral flow in the soil. And with regard to soil, importance of soil in climate change, this picture shows how that top 2 centimeter of soil itself holding 2,400 gigatons of carbon. So we can sustainably manage the soil to mitigate the climate change by assessing the soil texture. Then with regard to importance of soil texture in agriculture, first one, for selecting the suitable crops, it is useful. And nutrient management, it is playing a major role. And for irrigation scheduling, then tillage preparation, and finally, it is into one of the soil health indicator. Then traditionally, we are following the conventional methods like international pipette method, then hydrometer method, and then field method. But although it is having a good accuracy, but all these methods are cumbersome. But field method is having poor accuracy compared with others. So and time consuming, and it is involving hazardous chemicals to assess the soil texture. So as a alternative, we come up with a new technology called machine learning algorithm. These algorithms like predict the any property based on the input data we are giving or training the model, and it will rapid and economic and eco-friendly quantification of soil texture. Then in the machine learning also, we have accurately, clearly selected the CNN model, because CNN, what is CNN? CNN is a deep learning model, and it will analyze the images, and it will predict the images very accurately compared with other models. And how it work means, it having the hidden layers like convolutional layers, pooling layers, and fully connected layers. All these layers are the interlayers which will train the model through their data evaluation. And why we use the CNN for soil texture prediction? Because soil is a highly heterogeneous and complex in nature. The CNN also have the ability to learn the complex patterns from the images. So we taken the CNN as for the soil texture prediction here. And these are the objectives we have taken. First one, we developed the soil texture predictive model through the CNN. And second objective, we have validated the CNN model with the conventional method. Then this is the broad methodology we have followed. First, we have collected the soil samples, and we have analyzed all those different textures of soil samples using the international pipette method. And we got the which soil belong to which texture. And after that, we segregated those texture into different textures. And then we went for a smartphone-based image capturing of those textures. And that images was converted into these machine form like image extraction and image processing. We have utilized these heraldic features and LBP algorithms, and we have built the model by using we divided that image data sets into two training data sets 80% and testing data sets 20%. The training data sets we used to train the model, and that 20% of the unknown testing data sets we used for the validation purpose. Then we finally model we have developed. Then this is the important step we have done, because this research is based on image-based prediction. So first we captured the soil smartphone-based captured images, and then we went for image augmentation. Image augmentation is the important thing in improving the prediction accuracy of the model. Because here, for example, we have taken for sandy clay, if 100 images means that 100 images was augmented into 1,000 images based on different rotations and cropping and encircling. So for that, we have used image augmentation technique, and image annotations. We have labeled the images with the computer learning method, and we have subsetted the images using feature extraction. We have extracted the each and every portion of the images using the subsetting method. Then these are the results we got. We got the robust accuracy of 0.91 or 91.94%. For validation, we have utilized the appropriate statistical tools like confusion matrix. We got a kappa value of 0.8, which is a reliable value for in the prediction of this model. Then this is the trend of predicted accuracy we got for the sandy clay texture alone. Here we can see on the fifth epochs, we got the highest accuracy. Epochs is the one iteration through which the machine learning algorithm will learn the one cycle. For that first epoch, we got a lower accuracy. Then we went for data augmentation. Second, over the period of data augmentation we got the accuracy increased at the fifth epoch. Then as a conclusion, it is a climate smart approach since it does not involve any hazardous chemicals to assess the soil texture. And a mobile application can be developed by incorporating this model into the mobile-based interface. And future studies like soil organic carbon prediction models can be developed similar to this. Then finally, I'll say thank you with the quote: "Soil has an incredible potential to mitigate the climate change. That for all is how we use the soil sustainably. That is the matters." Thank you.
Thank you. Time for the presentation is 6 minutes 32 seconds.
Shake.
Yes, ma'am.
How many images you have taken for this machine learning?
Totally 1,200 images, ma'am.
1,200.
Yeah. Over the period of augmentation, we got like 10,000, 12,000 like that.
The textural classes you have determined.
Ma'am, almost all texture classes we have covered, but some of the texture classes we didn't get that much images. So as for the sake of that one or two samples only we have analyzed. We didn't get that silt loam and silt text, pure silt we can't get. That's other textures, clay samples we got many things. We have analyzed clay samples more and sandy clay and sandy texture also we got more. And the main thing is here we using the international paper method we analyzed so many samples initially we got so many errors because that is like a very accurate only. We if we do all the process then only we got the final results accurate. Initially we have got some error, then we have managed, then we have analyzed more and more sample, we got these results. This study was conducted in AC Center in Madurai.
So clay texture, we can predict it very well by using this.
Yes, having higher accuracy. Yes.
So, Abhishek,
Yes, sir.
why you choose that convolution method for this?
Yes, sir. Yes, sir. Actually, machine learning algorithm all are having like it will learn complex methods, but this convolutional neural network is having peculiar characteristic of recognizing the image-based detection. For example, if you are taking one image, means that image, that convolutional layer, which will separate into 4 boxes. That 4 box again separated into 8 boxes. So it will subset those images and it will analyze the complex relationship of that particular image peculiarly compared with other models.
Okay. Next, texture is it's varying over the layers.
Yes.
How can we use this methodology for different layers of soil?
Sir, in our study, we didn't have any subsoil samples. Sir, first we have analyzed all those surface soil samples only.
Thank you.
So whether your method can be applicable for the in situ determination of the soil texture, or that can be after collection of the soil sample, we can do that.
You have processed and in situ we didn't ban, sir. We have collected and we have sieved and we have finally analyzed. Based on that only we have taken photo. In situ we didn't do.
Okay, because you are spreading it in a single layer, no?
Yes.
So before taking the image,
yes,
if any overlapping of the particle or anything there, how we can?
We have sieved using 2 mm sieve, sir. After that only we have taken all the smartphone based pictures.
You have to keep it in a single layer.
Yes, yes, sir.
After that only.
Yes,
if
yes.
any possibility of overlapping of soil particles below that or over that.
No, sir. Maximum we have taken like uniform only, sir.
Okay.
Yeah.
So in that case, how will you differentiate that organic matter content in that? If the organic matter content is there in the soil, it may sometimes reflect in different soil texture.
Chances are there.
So how will you avoid that one in your methodology?
That's what only, sir. We didn't taken organic carbon as a one factor here. If we taken that also, the model will be fine tuned. Otherwise, it would be like one like
drawback will be there.
Yes,
yes. How will you overcome that one?
Sir,
any idea about it?
Yes, sir.
Overcome that?
We can include the organic carbon status also. We can include, sir. While I'm in, for example, I'm training the model with texture data alone. I can include some organic carbon data also. But in my PG research, I didn't get that much time to analyze organic carbon also because texture itself it taken a lot of time and a lot of efforts.
Because you have to get the single separate soil particle.
Yes, yes.
Otherwise, if any conglomeration or agglomeration is there,
yes, yes.
How will you make it as a single entity? Some
sir, we can include
practical
yes, correct. Sir.
Problem will be there.
Yes,
that has to be rectified in
yes.
future line of work.
Yes, thank you.
How many samples you analyzed by international paper method for your thesis?
Sir, totally 90 samples. It covering almost all textures. Sir.
90 samples.
Yes, 90 samples.
Okay. What is that the international pipette method you used? That is Robinson pipette, right? Robinson
yes,
pipette.
Yes, Robinson.
What is the volume of that Robinson pipette?
20 ml. Sir.
Have you assured that 20 ml is there?
Yes, sir.
How did you know that it is 20
sir,
ml?
I have once I pipetted, then I transferred into measuring cylinder. Also, I once checked.
Have you checked it?
Yes, checked.
After one used it?
Yes.
It was exactly 20 ml?
Yes,
in which lab you used?
Sir?
In which laboratory you analyzed that pipette?
East Center Madurai.
Madurai.
Yes, yes.
Have you checked it?
Yes, sir.
Are you confident?
Yes, sir, sure.
Questions from student side? Thank you. Next presenter is P. Lal Munzala, presenting Monitoring the Drought Dynamics in Southern Tamil Nadu, a 30-year analysis using SPI and MAI.
Good evening, everyone. My name is Bilal Monzole, and I am here to present my master's research on drought analysis and drought monitoring during in the southern region of Tamil Nadu using SPI and MAI. SPI being standardized precipitation index, and MAI being the moisture adequacy index. Let's give a short introduction. We all know that drought is one of the worst natural disasters that occurs naturally. It affects every one of us, and it affects each and every of our livelihood and each and every of our activities. And also, India is one of the worst stricken and the most vulnerable countries in the world to be affected with drought. And the intensity of drought is expected to increase as per the studies over time with respect to climate change. And also in the southern region of in the southern Indian states, especially in Tamil Nadu. Tamil Nadu is, since it is being rain shadow during southwest monsoon season, we can say that it is most vulnerable during the southwest monsoon and during the north, as compared with the during northeast monsoon during as compared in respect to droughts. And here, our study area consists of 10 districts within the southern districts of southern region of Tamil Nadu. We have taken Dindigul, Madurai, Pudukkottai, Sivagangai, Tenkasi, Theni, Thoothukudi, Tirunelveli, and Ramanathapuram. And for the rainfall data sets, we have obtained rainfall data sets from our respective TNAU observatories within the state. And also where for those districts in like Ramanathapuram, Tenkasi, and Sivagangai, where we couldn't find a continuous and good observed data, we have used IMD gridded datasets at 0.25 degrees. And here's basic methodology. We have combined both observed data and IMD gridded datasets. We have compared these two datasets, and we have already presented. It's already been presented before, and we have a good correlation between those things. And for those things, from those things we have derived SPI and MAI from the observed datasets. And let's look at the seasonal rainfall distribution. Here we can see that during the Tamil Nadu region, especially in the southern region, from the data that we observed, it gets more rainfall during the northeast monsoon season, and that makes the northeast monsoon season slightly more critical as compared to the southwest monsoon, and this makes the southwest monsoon season more susceptible to droughts. And coming to the value based on SPI. And SPI value on an annual scale and southwest monsoon and during the seasonal SPS distribution we have studied. And during the annual scale, the highest value was observed in Madurai with a value of 2.8, and the lowest value was observed in Pudukkottai with a value of minus 3.3. And during the southwest monsoon, the highest value was observed in Madurai with a value of 2.8, and the lowest value was observed in Pudukkottai with a value of negative 3.3. And during the northeast monsoon, the highest value was observed in Theni with a value of 2.6, and negative value was observed in Tenkasi with a value of negative 2.7. And from here alone, we can see that the southwest monsoon, the negative value is slightly more lower than that of the northeast monsoon, and we can see that. Here we have drawn a drought intensity, frequency map from 1991 to 2020. And from here, we can see that during the southwest monsoon, almost all the entire districts are slightly more vulnerable to moderate to mild to moderate drought. And during the northeast monsoon, certain districts like Dindigul, Theni, and Virudhunagar, sorry. They are more susceptible to droughts. And as per the SPI, what we have studied is that the districts of Vidyanagar, Pudukkottai, Dindigul, and Thoothukudi are one of the most drought-prone districts within our study region. And moving on to moisture adequacy index, we can see that mild drought and moderate drought is one of the most prominent in this region, and the amount of the number of mild drought events was highest in Tirunel Valley, followed by Tenkasi and Thoothukudi. And here we see the drought frequency map again using MEI, and and we can see that regarding all the droughts, all the type of droughts cumulatively, we can see that the districts of Tenkasi, Teni, and Tirunel Valley, and also some parts of Virudhunagar and those southern districts are one of the most during this period. Is that and for this MEI, we took the weekly MEI values, and we took the weekly MEI values from week 35 to 52, and from week 35, which correspond to the mid-September, and week 35 to 39 shows that this region is a particularly exceptionally prone to extreme drought events. This may be due to the overlapping of the southwest monsoon and northeast monsoon. So I would like to conclude that during the rainfall distribution, in the rainfall distribution study, the majority of the rainfall was observed during the northeast monsoon season, and this makes the southwest monsoon, which means that the region sees more intense droughts during the southwest monsoon season. And the analysis of SPA indicates that the region is more susceptible to drought during the susceptible to drought during the southwest monsoon as compared with the northeast monsoon. And Thoothukudi, Dindigul, Pudukkottai, and Virudhunagar are most prone to drought events. And the weekly drought events reveal that, as I have said before, one interesting thing that we have found was in the weeks 35 to 39, which means the first initiation of the first few weeks of northeast monsoon onset. We have seen that this region was more prone to severe to extreme droughts. And apart from that, Tenkasi, Virudhunagar, and Teni are observed highly vulnerable to drought. And I would like to conclude with the point that using a single drought index may or may not give a valid reason to define the drought events. And so we can go for a multispectral multi indices or an ensemble for observation methods. Thank you.
Thank you. Time taken for the presentation is 7 minutes 23 seconds.
Actually, you have measured observed data and also the IMD gridded data.
Yes.
So what is the percentage of accuracy you have observed?
For most of the districts, ma'am, in those kind of observations, the correlation coefficient, it hardly crosses 0.6. So everything is in the range of 0.4 to 0.58, something like that. The correlation coefficient, it lies between percentage of accuracy. I didn't check that one, but I did as per the correlation coefficient, and from that I got around 0.4 to 0.5 value range. And certain studies have shown that comparison of IMD gridded studies, means the gridded observed data sets, it shows a value of around 0.6 maximum. So in that we can with good confidence we were using that data only.
So based on your study, you came to conclusion that Tenkasi, Tirunelveli, Virudhunagar, then one more district.
Pudukkottai.
Pudukkottai. So these 4 districts faced highly vulnerable to moderate. So among these 4 districts, which one is that is the number of frequency of drought is more in which district, and the intensity of the drought is in which district?
The highest was I think it was in Virudhunagar. Virudhunagar, nearly 20 out of,
Intensity.
yes, ma'am. Around nearly 20 out of 30 years we have studied, they observed at least once in those years.
Okay.
And the results are almost similar between those among those four districts.
So you told that there's these districts going to have moderate drought. How do you define that moderate drought?
Moderate drought, as per the classification, is there, sir. As per the SPI, moderate drought happens when the SPI value is in the range of 1.49 to 1 to 1.49. I mean, yeah, on the negative side. And as per the MEI, if the value is between 0.25 to 0.5, we can call that as a moderate drought.
Okay, okay.
So we have done an 30-year analysis using SPI and MEI. So what is the practical utility of this?
Sir, from this we can develop some the most vulnerable regions within within a study area. We can see that this region is the most vulnerable to drought, and therefore we have to come up with some drought maneuver. We have to maneuver some new techniques in order to overcome, if that may happen. For contingency planning, it may be for contingency planning, it may be for drought mitigation planning, it may be for the planning issues. That
Okay,
for some
with this strategy, can you predict another for next 30 years? How it will be? So based on that, can you give any cropping sequence or cropping pattern, which crop is suitable for that? Is the type of any strategy is in your mind for kind of work? Is it possible?
It's definitely possible, sir. But in order to do that, we may need some more insights. We may need some more remote sensing insights. We may need some more data. We may need, sir.
Okay. Can do some prediction model with that also.
Some prediction model we can derive from the past models, sir.
Okay.
And using machine learning, we can do so. Okay, thank you.
Thank you. Next presenter, K. Pugarendi, presenting drought analysis over monsoon of Tamil Nadu utilizing seasonal forecast.
Good evening to one and all. Good evening to students also. This is the last presentation, don't worry. Here you will get some ideas about the history. My classmate has discussed about the history of SPA and drought analysis. I am also here to give some information about the history of, I have mentioned about forecast. What's a forecast? Why it has been used? You know, the history says that world has developed many more technologies. One of the technologies, weather forecast. They have used weather forecasting against Russia, that is America. They have planned, but that is not succeed on that time due to the computation power. You may think that your mobile processor, AMD or Ryzen and Intel, whatever may be, but they are developed because of your personal purpose, not at all. It is developed for the forecasting purposes. During that time, the development, IBM was initiated because of the need of more computation power that is required for weather forecasting. The model is, I'm giving some little idea about the model. Model is nothing but compressing all the whole world into a simple physics equations. It is governed by 7 physics equation, and it is converted into a mathematical model, which is calculated for each and every point of the world. You can simply get the forecast from this model. You can give the current status. From that, you can get the futures of the forecast using that physics calculations only. Now, let's enter into our topic. That is drought analysis over monsoon of Tamil Nadu using seasonal forecast. Over the history says that all over the India, agriculture universities are thinking about simply teaching about the theoretical aspect. But the only university which get into the practical field is our Tamil Nadu Agriculture University, which is providing, I don't know how much of you know that Tamil Nadu Agriculture is providing weather forecasting using separate portal and websites. If you have any time, please visit our website town.tna.ac. And then we have during that time our beloved Dr. R. Jaganathan sir has initiated the medium range weather forecast. That is only 5 days forecast. Whatever you are seeing today that is medium range weather forecast. And during that time he has developed, and then which is now refined and managed by our department. Then this study is nothing but there are how Sarah has asked about what is a drought we can predict in future or like that. This is the study which depicting that future prediction of drought. My both the chairmen, Dr. Geeta Lakshmi ma'am and Jagannath sir has initiated this study to predict the future, that is seasonal forecast, how it will be useful for farming community. Especially we are lagging. Tamil Nadu is gambling of both the monsoon. We will simply say India is a gamble of monsoon, but Tamil Nadu is experiencing both the southwest and northwest monsoon very critically. We are very difficult to predict that. If we see about India level, they will simply talk about southwest monsoon, but they will not mostly consider about northwest monsoon, which is very very important for our Tamil Nadu. Here, our study is mostly important on. Very, very important on predicting the southern part of India. Here I am taking season in 2013. World Meteorological Organization has developed two institutes developed on a project that is called subseason to seasonal prediction. That is now we are utilizing is subseasonal prediction, that is up to 10 to 15 days. They are extended all over the world are interested in predicting the seasonal forecast. So they have made a project called subseason to seasonal forecast, and then all over the country, around 13 countries are involved in that. Only the 6 are open sourced for evaluating these models. They are short formed because they are in different German and Spanish words. These models were taken for analysis, which is better for our region. This is simple global forecast, which is very, very high resolution, around 100 kilometer resolution. In that resolution, we only tell about the accuracy, not about the how much it is very, very useful to our location. So first of all, we are predicting. We have utilized one error metric called RMSE. It is very, very more common at all. But in this case of forecast verification, RMSE is very, very important. This is a preliminary error metrics to measure that. And then we have I have analyzed for both the monsoon, northeast monsoon and the southwest monsoon. For both the monsoon, in modeling purpose, they will tell about spinning time. That is, if model is initiated 1 month prior to the forecast time, that 1 month will stabilize the model to predict accurately. Like that, I have taken 3 months, up to 3 month lead time. 1 month before, 2 months before, 3 months before. Like that, 3 lead times I have taken. And then I have predicted the, evaluated the forecast. And then I have evaluated the forecast, which is better, which is suitable for drought prediction. These are some results I have got. Just for your explanation, I'm saying this row wise are simply, these are models. And then the column wise are, first 3 columns are northeast monsoon, next one is southwest monsoon. In simple form, this is for the southwest monsoon. Among the 6 models, if it is very, very complicated to come to conclusion from this pictorial representation. You can see the last model, that is UK model, UK Met model. It is very, very intense at the Kerala region. That is southwest side. During southwest monsoon, that prediction will be RMSE values are gone up to around 400 mm. That is for around 1100 mm. It has predicted over prediction, that is 400 mm extra it is predicted. However, in our Tamil Nadu region, it is predicted very, very less bias only occurring here. While in the case of northeast monsoon, very, very important for our Tamil Nadu region. Here you can see about ECMFW model. That is this 4th column. Here you can see it is very, frankly speaking, very difficult to identify with the numerical values only. I am explaining that ECMW is having very, very low RMSE values. So these are suitable for our region. And I have utilized these models for predicting the future SPA values. I have taken on very severe drought year in India. That is 2016. IMD has declared a very severe drought year. And then I have compared I have iron-casted the model. Iron-casting is nothing but using the model forecasted value and then comparing with the past values. I have utilized this and I analyzed. I have got for Southwest Monsoon ECCC model and then UK Met model as a best model, which is very predicting near to the observed value. This red color denotes the observed SPA values. These are the forecasted values. Like that for Northeast Monsoon also, along with ECC and UK model, DW model is also predicting very good. With this conclusion, what I'm going to is this is a preliminary study. With this, that 100 kilometers is spatially converted, that is downscaled to 4 to 3 kilometers, and it has been going to be tested for the accuracy of block level or village level. So this is a preliminary study which is depicting that, and then among these ECC model and UK model is very best for our seasonal forecast, seasonal drought prediction. And this is a preliminary. We can use this for developing dynamic crop weather calendar like that. Thank you, ma'am.
Thank you. Time taken for the presentation is 8 minutes, 3 seconds. 8 minutes, 3 seconds.
Lindy. Actually, we are providing seasonal forecast, southwest monsoon, during last week of May.
IMD is providing seasonal forecast
May
at 3 times, ma'am. They will provide it 3 phases. Okay.
Okay, for southwest monsoon, we are providing forecast at present, last week of May. And
Yes.
for northeast monsoon, September last week.
Yes.
And so based on your study, so we can give the forecast in little bit earlier.
Of course, ma'am. I said in this 3 lead time I have taken. In the 3 lead time, I have in the result I have doesn't mentioned first lead time for April. Southwest monsoon April lead time is performing better than other 2 lead times. Like this northeast monsoon, however, only 1 month lead time is performing better than other 2 lead times. So we have to optimize more runs. We have to run again and again, which is providing more appropriate, very less bias value, which is predicting near value. So we have to pick that value. If the lead time which is very far away, that is 2 months far away, it is giving more accuracy, means we can utilize that for a better accuracy forecast.
So we are giving this district level seasonal forecast. So this forecast information will be passed to all the district level officers. How it will be useful other than the agriculture department or agriculture colleges or agriculture research station than others?
Yes, of course. This not up to the only this is we can speaking up to farmers level also, we have to value add and we have to provide. But it is as a raw, it can be not useful for farmers also. But it is useful for any of the policymakers or any higher level authority, resource management or anything for in the higher level authority, we can utilize these 4 cases.
You have told some interim correction.
Sir, I can't get you.
Every 3 months, sometimes some variation may be there.
Yes, sir.
You are doing.
That's a spin time.
Oh. So is it possible in that? How about the accuracy of that?
Yes, of course, it is approved. I mean, for IMD has reported that 1 month spin time is optimum for getting better results.
Okay. Some
Actually,
question of variation may be
sometimes model will take 1 or 2 days to stabilize because initial values we are not providing equally all over the world data. There may be some missing data that will be interpreted and is given. When it is started simulated, it has sometime during initiation, it may over predict at some places and then it will come to stabilize the model. So it takes some time to stabilization.
So that stabilization process is there in that modeling actually. No? Stabilization process is there.
If we, that is a research purpose, we can do means if we can perform and then check whether it is taking a better spinning time, or for in case of our medium range forecast, we are not taking any spinning time. We are not taking any stability, because the data given is very, very accurate and it is predicting for only just 5 days. But in the case of seasonal forecast, it is predicting for around up to 9 months to 12 months, it will be predicting. So for that long period of time, it needs some stability. So that only the global circulation will come into the action of the model.
Good evening, everyone. As we come to the end of the oral presentation session on the crop dynamics, soil crop dynamics, trends, challenges, and solutions, I take immense pride in expressing my gratitude to everyone. First, I sincerely thank the chairman, Dr. K.J. Jayabhaskaran, Principal Scientist, Soil Science, ICAR, NRCB, Trichy, for enlightening us with his comprehensive presentation and guiding us through the course of the session. I extend my sincere gratitude to the co-chairman, Dr. P. Balasubramaniam, Director, Natural Resource Management, and Dr. M.K. Kallarani, Director, Crop Management, for their continual support and interest in leading the session. I sincerely express my gratefulness to Dr. D. Selvi, Professor in Soil Science and Agricultural Chemistry, Dr. P. Parasuraman, Professor and Head Agronomy, for accepting our invitation and encouragement. I thank the faculty rapporteur, Dr. Ga Deepakaran, for his active contribution. I thank all the oral presenters for sharing your commendable research outputs. I thank everyone who contributed in making the session a noteworthy one. Thank you.
Once again, thank you one and all for the great event. Thank you.